In this video, we will cover the topic understanding the power, sum, and constant multiple rules. Let's look at the following problem. If f of x equals 3x squared, what is f prime of x? We can solve this using the limit definition of the derivative, which we know as f prime of x equals the limit as h approaches 0 of f of x plus h minus f of x over h. Substituting the above function into the limit definition of the derivative, we can solve for the derivative via the following steps, which you should already be familiar with. Doing this, our answer is that f prime of x equals 6.
Is there an easier way to get the same result?
Yes, there are derivative rules we can follow that lead us to the same solution. The rules that we will cover are the following: the power rule, the constant multiple rule, the constant rule, and the sum and difference rule. In order to differentiate the function that we derived using the limit definition, we will need to use the power rule and the constant multiple rule. First, we will look at the power rule. The power rule states that the derivative of x to the n is equal to n times x to the n minus 1. When a variable has an exponent, we can follow this rule. Essentially, you multiply the variable's coefficient by the exponent, and then lower the power of the exponent by a value of 1. Let's look at the problem, what is the derivative of f of x equals x squared? If we take the function f of x equals x squared and apply this rule, we get that f prime of x is equal to the derivative of x squared, which is equal to 2 times x to the 2 minus 1. Which simplifies to f prime of x equals 2x.
Does this work for negative exponents?
Good question. If the exponent is negative, you will follow exactly the same process, but use algebra to set up the function in a better way. Let's find the derivative of f of x equals 1 over x to the 4th. Using algebra, we can rewrite the function as f of x equals x to the negative 4. Following the power rule, we get that f prime of x is equal to negative 4 times x to the negative 4 minus 1. This can be simplified to negative 4 times x to the negative 5, which can be rewritten as negative 4 over x to the 5th. Now the power rule can be added to our list of rules for differentiation. You may want to write this list in your notes.
What about the constant multiple rule?
The constant multiple rule states that the derivative of a constant multiplied by a function is equal to the constant multiplied by the derivative of the function. For example, the derivative of a constant multiplied by x to the n is the constant multiplied by n times x to the n minus 1. Let's look at the problem. If f of x equals 3x squared, what is f prime of x? If we take the derivative of f of x equals 3x squared using this rule, we get that f prime of x is equal to the derivative of 3x squared, which is equal to 3 times 2 times x to the 2 minus 1, which simplifies to f prime of x equals 6x. Recall that we got the exact same answer using the limit definition of the derivative.
What if the function is just a number without any variables?
The constant rule is based on the constant multiple rule and states that the derivative of any constant will always be 0. For example, let's look at the problem, what is the derivative of f of x equals 6? We know that taking the derivative of f of x equals 6 is the same thing as taking the derivative of f of x equals 6 times x to the 0. We use the constant multiple and power rule previously explained, and we have that f prime of x equals 0 times 6 times x to the 0 minus 1. Thus, f prime of x equals 0. Therefore, we can say that the derivative of 6, or any other constant, is 0. Now we can add the constant multiple rule and the constant rule to our list of derivatives. Let's look at a new function, f of x equals 3x squared plus 2x. We will now use 3 rules of differentiation to find the derivative of this function. Those three rules are the power rule, the constant multiple rule, and the sum or difference rule. The sum or difference rule states that the derivative of a sum or difference is equal to the sum or difference of the derivatives of each term of the function, or that the derivative of f of x plus g of x is equal to the derivative of f of x plus the derivative of g of x, and that the derivative of f of x minus g of x is equal to the derivative of f of x minus the derivative of g of x. Looking back at our example, this means that we can take the derivative of 3x squared and 2x separately and then add them together. We can take the derivative of both 3x squared and 2x using the constant multiple rule and the power rule. Doing this, we get that the derivative of 3x squared is 3 times 2 times x to the 2 minus 1, and that the derivative of 2x is 2 times 1 times x to the 1 minus 1. Once we have simplified this equation, we find that f prime of x is equal to 6x plus 2. Now let's add the sum or difference rule to our list of rules. You can get more practice with these rules by watching the example video of this topic.